Okay, this is a video about the basic graphs, and so there are about 6 basic graphs. I'm also going to include x squared. I need to show you that one as well. Y equals x squared. This is a reminder to me. Sometimes that one's included on this list. But these are the basic graphs that you need to become familiar with, so that you are good at sketching them. So a sketch is kind of a quick drawing of something. It's not, every point is not exactly accurate, but you've got the basic shape down. So this is f of x is equal to x to the third. A good way to get a feel for that is to point plot like we did on the very first worksheet that we did together. But if you were to point plot, and I'm not going to take time to do that right now because we've already done that on a different video, you would see that this graph, x cubed, has the point 0, 0 on it. It has the point 1, 1 on it. It has the point negative 1, negative 1 on it. And it basically looks like this. This is the shape of x cubed. All right, the square root of x. This has domain issues. You are not allowed to put negatives under here or else you get imaginary numbers. So the numbers you can put in are 0 and 1, and maybe I might want to put in 4. And we've already done stuff like this before. The square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So we'll get a few points on here just to get ourselves going. So we get this point 0, 0. We get this same point 1, 1. And then over here 2, 3, 4. We're up here at 2. And so this is the basic shape. It continues to go up. But this right here is the basic shape of the square root of x graph. The cube root of x graph, what does it look like? Well, the cube root of x, and you are allowed to put negatives into an odd index because you do not get imaginary numbers, you just get real numbers. For instance, the cube root of negative 1 is negative 1, and the cube root of negative 8 is negative 2. So there's no problem with those right there. So we could plot some points, but what you would find is that this one has the basic shape. It's coming in here like this. It's sort of like x cubed, only it's sideways. That's what the cube root of x looks like. The absolute value of x is always a V-shaped graph, and it is centered at the origin. So this is what it will look like. This is a line. It's got a slope of 1, and this is a line, and it has a slope of negative 1. F of x is 1 over x. This is a rational function. It also has domain issues. And the problem is you can't divide by 0. So if the denominator is 0, it's trying to divide by 0, and it knows it's not supposed to do that, and it freaks out. And so this is what this graph looks like. It's very weird looking. Where x is 0, it's the y-axis. So on this side, it's shooting up to infinity on this side, and on this side, when it gets close to 0, it is shooting down to infinity. So this it's in 2 pieces, sort of, and that is what 1 over x, and this is called the reciprocal function, is what we call that. F of x equals to x. This is a line, and this is y equals x, or y equals mx plus b. The slope of this line is 1. The y-intercept of this line is 0. So this is going to be up 1, right 1. It's going to be a line that cuts through the origin, just like that. That is what it looks like. Now, last week we talked about giving some functions. These are all functions. We talked about giving some functions names, like are they even functions? Are they odd functions? Are they not either, not odd? Let me graph y equals y squared, x squared. This is a parabola centered at the origin. It basically looks like that. So let's go through these 7 graphs. I'll call him number 7, and we're just going to say, give them a label. Are they even? So you don't have to do anything except for just have a look at them. Look at the graph and say, does it look the same way on both sides of the y-axis just when you look at it? Well, here, no, because I don't see anything on this side. I would see a mirror image, so this is not even, right there, not even. Right here, is this even? No, because if it was, I would see something on this side, not even. How about this guy? No, I would see this something over here, not even. What about this guy? Yes, it's got a mirror image across the y-axis. That is an even function. Even. What about this guy? No, I would see something over here. I do not. This is not even. What about this guy? Yes, it looks the same on both sides. This is even. What about this guy? No, because if it was, I would see. Just looking at it, I would see something over here. This is not even. Okay, let's go through and say, hey, are they odd? Can we figure this out? Are they odd? Odd, to figure out, if something's already even, then it's not going to be odd. So we don't have to worry about 4, not odd. We can say this is not odd. We don't have to worry about number 7. This is not odd. But the rest of these are potentially odd. So what's the test for that? Well, first you reflected about the x and then the y, or vice versa, but it's going to land in the original spot if it is odd. So let's just do a reflection about the x. So if I do it about the x, then this side's coming down here. Here's the intermediate part. This side's coming down here, and this side's going up, this side's flipping up here. And then about the y, this little green part's going to fold over here, and it's going to hit that blue, and this is going to fold over and hit that blue, and it's going to land in the original spot if I do both of those rotations. So what this tells me is that this is, yes, it is an odd function. Let's do the same thing here. Let's flip it about the x, okay? Then it would be down here. If we take this intermediate part and flip it about the y, then it's going to be down here. Did it land in the original spot? No, it did not. This is not even, and it's also not odd. Well, what about this guy? Let's flip it about the x. That means this part's coming down here, and this part's coming up here. Now let's do it about the y. This part is going to flip across the y, and it's going to flip right over there. It's going to land right on that. This part down here is going to go across the y, and it's going to land right like that. And it does match, so this is an odd function. What about this? No, because we already said, oh, what about this? Let's do this. About the x, okay? About the x, this part's coming up here. This part's coming down here. Now about the y. Okay, about the y. This part's flying over here, and it's going to match that blue. This part's coming back over here, and it's going to match that blue. And so this is an odd function. No, that's even. How about this guy? Let's flip it about the x. This part's coming down here. This part's coming up here. About the y, this green part's going to go over there and match the blue. This is going to match the blue, so we can say that this one is an odd. Let's just take note of one thing before we move on. What can we say about the odd functions? Let's see, this one was odd. Notice where the function fell naturally. It fell in quadrant 1 and quadrant 3. How about number 3? Where did this function fall? It fell in quadrant 1 and 3. This one fell in 1 and 3. This one fell in 1 and 3. So that is just interesting. They were in quadrants across from each other when they were when they turned out to be what am I trying to say? Odd. Now, could it be in quadrants 2 and 4? I believe it could. Let's graph this guy just to test that out. What if we had f of x is equal to negative x? What would that graph look like? That's got a negative slope, and it's passing through here. Is this an odd function? Well, let's reflect it about the x. Okay, you're down here, you're up here. Let's reflect it about the y. You're here and you're here. So it could be in quadrant 2 and 4. But here's what I want you to see. An odd function will naturally fall in quadrants 1 and 3 or 2 and 4 across from each other. Okay, that's the basic graphs. In the next video, we're going to start using transforming graphs. What I didn't do in this video, but I'm expecting you to do when you turn it into me, is to write down the domain and the range for every one of those functions. We drew them. We talked about even and oddness. I want you to write the domain and range in interval notation. Awesome.